Welcome to Tech Teach.
The next point is design of asynchronous counters. So we will be having the similar steps with a few changes. So we will just thinking of like how. So yes, in this synchronous, we are having the counting that it can be in any order, but in asynchronous there will be a limited counting. Okay, so limited sequence. There will be a limitation like it cannot be a random. So here in asynchronous, counting order is fixed. So what is that fixed? It could be either up counter or down counter. So up counter in the sense it will be counting 0, 1, 2, 3, 4, 5, 6 likewise. In down counter it will be like from 6, 5, 4, 3, 2, 1, 0 likewise. So this will be the down counter. So in case of asynchronous, it could be either up counter or down counter. Its counting will be having a fixed order. Okay, and next is here in asynchronous, the flip-flops used is only either JK flip-flop or it will be having T flip-flop. This is because in asynchronous type of counters, toggling mode of flip-flops are required, and these two flip-flops supports toggling mode. That's why only two flip-flops can be used into asynchronous type of counters. The third one is basically here. So in case of third one, the point that we have just gone through is the clock is common. Yeah, in this synchronous, the clock is common. But in case of the third point is in case of asynchronous counters, the clock is not common to all flip-flops. So here clock is connected with only the LSB flip-flop and other flip-flops clock will be connected to the output of previous flip-flop. So in case of asynchronous type of counters, the first step is like it will be having fixed counting, and the flip-flop that it will be using is either JK or T flip-flop, and the clock will be connected only to the first clock or first flip-flop that will be the MSB flip-flop. So in case of implementing the counters, some counters or some flip-flops are considered as MSB1 and one is considered as the LSB. So as in synchronous also. So here we just say, so here we have considered like D2. So D2 is here MSB. So this is D0, so it is LSB1. So in this respect only we have considered every state diagram and its states and all. So similarly in case of asynchronous, whatever the flip-flops are there that are connected directly with the clock, that will be considered as the LSB1, that is fixed. Okay. And other flip-flops will be having its clock connected with the output of the previous flip flop. So the same thing we will be understanding by an example. We will be looking at an example like how we can implement it. Okay. So for suppose we are going to implement or design of mod 5, design a mod 5, design a mod 5 asynchronous counter by using T flip flop. So suppose this is the question. So in the question it is given like you need to design mod 5 asynchronous counter by using T flip flop. So first of all, while any designing concept designing question will be coming, you need to identify which type of counter it is asking about. So it is asking about asynchronous. So asynchronous in the sense all the flip flops will not be having a common clock, that is per se. And here mod 5 is given. So mod 5, its meaning is the counter will be having 5 states that we have already seen. So if mod 5 is given in the sense 5 states will be there into the counter. So first step is like we need to find out number of states. So number of states are 5. Then number of flip flops required we need to find out. So that will be the n, that is log capital N to the base 2 or log capital N is here 5. So log 5 to the base 2. So this n should be greater than or equals to this one. No, this is equal. So here n will be greater than or equals to whatever value it is coming out to be here. So once you will be coming out to be there, it will be something 2 point something or it will be there. So here the n value we can regulate n should be greater than log 5 to the base 2 or n will be at 3 or the first of all this n number of flip flops will be an integer value. So we need to find out the integer value, whatever is that, because it is 2 point something, it will be coming out. The next integer will be 3 only. So n is coming out to be 3. So its meaning is 3 flip flops are required. So 3 flip flops are required. So 3 flip flops are required. So what will be the states here? So we need to draw the state diagram. So state diagram, it is mod 5. So it will be starting with 0, 0, 0 because 3 flip flops are there. So 3 bit counting will be there. So 0, 0, 0, then 0, 0, 1, then 0, 1, 0, then 0, 1, 1, then 1, 0, 0. So the states will be 5 states. So after first, the second state, then third state, then fourth state, then fifth state. And after that, again, it will be going to the first state. So this is the state diagram. So once we have a state diagram, we can draw the state table also. So in the state table, we can get like what is the previous state and what is the next state. Okay. And similarly, the excitation table for the flip flop. Go to the implementation because we have some limitations here. So limitation in the sense we are having the flip flops. So 3 flip flops are there. So we will just going to see. Okay. So these are 3 flip flops. This is the T flip flop. So T2, Q2, and this is Q2 bar. T1, Q1, Q1 bar. T0, Q0, Q0 bar. and there will be a clock. So in the previous class, once we were discussing about the asynchronous counters. So in that I have told you, like, if we are using the clock, if we are using negative edge triggering, this is the clock. We are using negative edge triggering of the flip flop because it is an up counter. It is an up counter. So in case of asynchronous, if it is up counter and we are having negative edge triggering, then in that case, Q should be connected with the clock of the next flip flop. So if this is the case, so your clock of the next flip flop means T1 will be connected because this clock is connected with this flip flop. That's meaning this is the LSB one. So one thing you should be writing is this is the LSB one. So we should be modifying it because it is LSB, so it should be 0. So this is T0, to Q0 like this. This is 2, Q2, Q2 bar. So wherever the clock is connected, it will be the LSB one because it will be changing again and again. And here inputs, one more thing, the inputs are there here. So these inputs are always 1. So in case of the condition is in asynchronous counters, inputs of T flip flop or JK flip flop are always one, logic 1 only. Because in logic 1, when T is 1 or JK is 1, then only it will be working in toggle input. So input will always be 1 here for all the flip flop. So input will be always 1, and the clock, the LSB flip flop will be having direct clock connection, and other flip flops clock will be connected with this positive one. If we are connecting it with Q, then it will be the up counter. If it is down counter, similarly, if you want to implement down counter, so for down counter, if it is negative edge triggering, then for negative for down counter, the Q bar will be connected with the clock. But it is up counter, so we will be connecting Q with the clock. So this Q will be connected with the clock. Here again, the Q will be connected with the clock. So up to here, we have implemented a up counter, up asynchronous counter. So asynchronous counters are also called triple counters. So we have implemented it, but here the states are, it will be starting with 0. So all will be 0, 0, 0. So starting with 0, 0, 0, it will be going with 1, 2, it will be going with 2, it will be going with 3, then 4, then 5, then 6, then 7. After 7, again it will be going to 0. So this will be the general trend. But we want to implement the mod 5, means only 5 states should be there. So it will be ranging from 0 to only 4. So its meaning is from 0, 1, 2, 3, 4. So up to here we require. So but this is the circuit that will be going through all up to 7 and then again to 1 to 0. So to stop this counter, like after 4 it should be 0, 0, 0. This is like unwanted states. To remove this unwanted states, what is required is, because after 4 the 5 will be coming out. So it's meaning as soon as the 5 is going to be the next state, instead of 5 it should be 0, 0, 0. So to make it 0, 0, 0, in the sense we will be using the clear pin here. So there is a clear pin. So in each of the flip flop there is a clearing concept. Clearing concept in the sense, if clear pin is there, If bubble is there, that means if we will be providing 0, this flip-flop output will be 0. It will be cleared. If suppose it is bubble is not there, its meaning is if we are providing, this is the clear pin of the flip-flop. So if it is bubble is there, its meaning for 0, if we are providing 0 into the clear pin, it will be clearing out the output. That is Q0 will be cleared, means it will be reset to 0. If it is bubble is not there, its meaning it is cleared when one logic will be applied to the clear pin. So similarly, we will be using the clear concept here. So in the clear concept, basically, so we will be using the clear pin to clear out the output when the flip-flop is going to switch from 4 to 5. So as soon as it is going to switch 5, its meaning is at that time Q0 will be 1, Q1 will be 0, and at that time Q2 will be 1. So but this is unwanted state. So this Q0 is 1. So Q0 and Q1, Q2, these two will be 1 at that time. It will be 1 at that time. So these two will be combined together into an AND gate. So when both are 1, 1, so output will be 1. So 1 is 1. So now this 1 will be taken as the clear pin. It will be applied to the clear pin. Means as soon as the AND gate of this is 1, it will be clearing out the flip-flop. So clearing out the flip-flop in the sense, it will be clearing the output. So output becomes 0, 0, 0. So as soon as it come here, after that, it will be clearing the output to 0. So the only states that will be remaining is 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, and then 1, 0, 0. After 4, it will be going directly to the 0. It will not be going to the 5, because as soon as it will be going to 5, it will be, this condition will be satisfied. Clearing condition will be satisfied. It will be going to 1 here. So once it is 1, this 1 will be clearing the output. So output will become 0, 0, 0. So this is how the asynchronous type of counters are basically designed.